Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Multiple Integrals. Now we are on to the topic of Design Thinking Approach on Multiple Integrals. So first of all, the motivation behind choosing this concept is we have to connect the mathematical concepts with the real world problems. We have to connect the mathematical concepts with the real world problems, and we are also in the mood of in the perspective of problem solving. And multiple integrals extend single variable integration into higher order dimensions, higher dimensions, and it is also useful in physics, engineering, probability, and optimization. And also we can notice that design thinking makes learning or application more interactive, human-centered and problem-driven. And that is why we are approaching this multiple integrals concept and design thinking way. Now, what are our strategies? What are our strategies to be followed? In design thinking strategy, we usually notice that we usually notice that we have five major steps. One is empathizing, defining, ideating, prototyping, and testing. Now, what do you mean by empathizing? We are just going to understand students' struggles in visualizing and applying multiple integrals. How we will visualize it, how we will apply this multiple integrals. Next step is to frame the challenge. Next step is to frame the challenge. How can multiple integrals be used to solve real life spatial and probability problems? Next is to ideating. Ideating means formulation. Brainstorm approaches, geometric visualization, real world case studies and simulation also helps in formulating the problem. Next thing is to prototype. Prototyping means applying multiple integrals to practical problems like volume, mass or probability density, or even case study will do. Now testing. Validating with examples and reflect on accuracy and ease of understanding is also the major concept under testing. So these are the the important steps to be followed in design thinking concept. The first step is to empathize. What do we empathize here? Our students will also ask, how do we visualize integration over 2D and 3D regions? How do they visualize over 2D and 3D regions? The answer will be given here. And why are double and triple integrals important? The answer will be given here. And real world needs for 2D and 3D multiple integral problems are material volume, heat distribution, and probability over the regions. These are the 3 points which we empathize. Next is our problem statement. What is our problem statement? Students find multiple abstract. We need to design learning or solutions that make them practical, engaging and directly linked to engineering challenges. So we are in need of preparing an abstract multiple integral so that it will become a practical usage for engineering students. Now what is our ideation? Ideation is we are going to use 3D models and graphs to represent the integration regions. We are going to use 3D models. Three-dimensional models using computer graphics or CAD or AutoCAD we can use to apply this 3D models, and we can use integration for measuring the area or volume of the given multiple integral. Now connect with the real world examples. Example, in a volume of a dam reservoir, the probability of a random variable in a region. Here we will be using triple integral, here we will be using double integral. So connecting with real world examples is a major point to be noted in ideation processes. And also what we can do as group activity is brainstorming applications like mechanical, civil and electrical engineering. We can apply this brainstorming activities using this multiple integrals model. So the main thing to be noted here is volume of the dam reservoir and probability of random variable in a region can be applied or connected with the real world situations wherein the triple integral and the double integrations are applied. Now what is the prototype? Now what is the prototype? The prototype is nothing but in the case 1 we can use an engineering application. In the case 2 we can apply a probability application. In case 1 engineering application, to find the volumes of a solid bounded by surfaces using triple integral can be done, and relating directly to designing storage tanks or structures. What we can do after finding the volume of a solid? What we can do after finding the volume of a solid, we can use it for structuring or building up a storage tank or storage tank like structures. In case 2, Probability application. Evaluating probability of a particle in a region using double integral over probability density function. We already knew that we have a probability density function in the probability area, wherein we can evaluate the probability of a particle in a region using this double integral, which means the area can be found for the particle in a region. What will be the outcome? uh, Outcome is the deeper understanding of multiple integrals through design thinking can be developed, which means the students will get to know how and when these multiple integrals are applied, and they can visualize it in a greater way. And also the better visualization and real world problem connections are also being noted using the design thinking approach. Students become innovative problem solvers rather than the rote learners. Rather than mugging up the whole concepts from the book or the note which is given, they are becoming an innovative problem solvers using this design thinking concept. So this will be the major outcome of the design thinking approach of this multiple integral. Now conclusion. What will be our conclusion? Design thinking brings clarity, creativity, and collaboration in learning mathematics. So, students will be very much getting clear with all the concepts taught using design thinking approach. Multiple integrals move beyond equations, which is into practical solutions. So they can, whenever students are asking for the practical solutions using the concept taught in mathematics, this can be shown with them. Encourages students to think like engineers while learning math. So they can implement this mathematical concepts in their engineering core papers so that they can get more knowledge, and it encourages the students to build so. This design thinking approach encourages students to build so. So this is what our design thinking concept in multiple integrals have been applied. We'll continue this, or we'll share a few more concepts in the next video as well. Thank you.